All right, here is the test review for this upcoming test 7. And I just want to start with pointing out this phrase here, y varies directly with x. And so with that phrase, this is the green light for you to be able to set up a proportion. And why you can do that is because on your formula chart, when you see this in the linear equation where it has this direct variation varies directly, we have this formula for a line where k is our slope, but k is also the constant of proportionality, which is showing the relationship between your x and your y value. So remembering that this is where you divide both sides by x, and then you can solve for k in that manner. So whenever you see varies directly, you know that it is direct variation, it is proportional. So what I'm going to do on these problems is solve them using a proportion like so. So when you set up a proportion, you need to make sure that whatever is in the numerator and denominator is the same on the left and right side of the equal sign. So what I'm going to do is use y and x like this. You could also do x over y and x over y, but I'm just going to be consistent and do that y over x. So they're saying when y is 16, x is 24. What is the value of y? So we don't know what y is when x is 30. So this is where you can use your cross multiply and divide, the butterfly method, the baseball bat ball method, whichever you prefer. What you're going to do is multiply across. So 16 times 30 gives you, I think that's 480. Correct. So we have 480, and then we're going to divide that by 24. And so when we do that, we get y equals 20. Okay, so we're going to do the same thing. On number 2, we have y varies directly with x, so that's our green light to set up a proportion. So we have a proportion on both sides. So I'm going to do again y over x. So in this problem here, we have when y is 20, x is 45. And what is the value of y when x is 28? So again, we're going to cross multiply. So 20 times 28 is 560, and we're going to divide by what's left. So we're going to divide that by 45. So 560 divided by 45, we get y equals 12.4, and that's repeating. All right, on the next one, we have your distance from lightning varies directly. Okay, again, there's our green light, varies directly, means it's proportional, growing at the same rate with the time it takes you to hear thunder. If you hear thunder 10 seconds after you see the lightning, you are about 2 miles away from the lightning. How far is the lightning if you hear the thunder in 15 seconds? So I'm going to set up my proportion. So what I'm going to have here is I'm going to show you 3 separate examples of what to do or not to do. So in this first one over here on the left, if I did seconds to miles, that would be okay. You could do that. You could also do miles to seconds, and if I wanted to do seconds to miles, I would not be able to miles to seconds. So this would be okay, this would be okay, this one would not be okay. So whichever way you want to set it up, as long as you keep them consistent, you're okay. So what I'm going to do is I'm going to say if in 10 seconds I'm 2 miles away, how far away, so how far in miles is 15 seconds. And you'll see if I set it up on that opposite side to 10 we're going to be multiplying the same numbers, and that's why. So 2 times 15 is 30, divided by 10 is going to be 3 miles. Same here, if I do 2 times 15 divided by 10, you're still going to get that 3. So where you would go wrong is if you were to use this setup here. Okay, so that is on proportions, varies directly, direct variation, proportions. Okay, number 4 and 5, we have fill in the blank for something that represents a y as a function of x. So now we're going out of proportions and into the world of functions. We're looking for y as a function of x. So a function says that each input is related to only one output. Okay, so for this example here, every time the input 5 goes into a function, we should get a 7. Every time a 9 goes in, we should get an 11. Every time a 18 goes in, we should get a negative 5. So in order to continue this, we honestly could put any number here other than 5, 9, or 18. So any number other than 5, 9, or 18, so I'm going to choose 12. So that's continuing the source of it being a function because each of our inputs, x, is related to only one output, y. So then in this next example, we're looking for it to not represent a function. So they're saying what would happen if you, to fill in this blank here that I'm circling, what number would make this set of values not a function? So let's talk about if I were to put a 5 here. So originally we said if a 5 is my input, my output should be 7. And if I now put a 5 in, again, it should be 7. It should be 7, but this time we get a 6. That would be a way that this would not represent a function. This could also be a 9, because if I put a 9 in, I'm supposed to get 11, but then I got a 6. So if I put a 9 here, it should be an 11, but I got a 6. Okay, so each input can only be associated with one output. Okay, so there's your function example. So now we're going to look at using the graph to complete the table. So what we're going to do is look at, they've given us these pretty points here. So I'm going to use these pretty points to fill in my table. So I have a pretty point at 10:40. So I'm just taking these 10 weeks, $40. At 15 weeks, we have $60. And at 25 weeks, we have $100. So that's our savings. And we're looking to write an equation that models the relationship. So this is a proportional graph because it passes through the origin. And when we're looking at proportional graphs, we know that the proportional graphs come across in this form, y equals kx. So in order to write the equation, we need to solve for k, or our slope, when it is a proportional relationship. So to find k, we are going to divide our y by our x. So we have our x and our y, weeks. We see our x weeks, time or savings y. So if we take 10 divided by 40, sorry, that's backwards. 40 divided by 10, we get 4. And because it's proportional, all of these are going to be the same. We have 60 divided by 15 is 4, and 100 divided by 25 is 4. So in whichever y divided by x you do, you'll get the same one. And then this is our k that we just solved for, so we can substitute that 4 back in for our example. So then with number 7, we're looking at 52 weeks. So weeks is on the x, it's an x value. It's on the x-axis. So what we can do with we can use our equation. So y equals the amount of savings, because look, y is our savings over here. Savings is our y. Time is our x. So the amount of money savings equals 4 times the number of weeks. So they're asking how many will it be at 52. So we can take 4 times 52 and we will get $208. Okay, now we're going to look at these. So this says for each graph, find the slope of the line and describe the meaning of the slope. So what we need to look at is first, this one does not have any pretty points on it. What we're going to be looking at to find slope is the rise over run. So we always know with proportional graphs that our pretty points there's always going to be a pretty point at the origin. And then some of them are a little tricky to see, but we have our pretty points there and there. And we're going to want to pay attention to the interval on the x and y axis. So each of these lines that are counting, we notice that it looks like it should be 1, but once we're going up, we get to 10. So each of these our interval is going to be 2 on both the x and the y. So you just need to make sure pay attention to the intervals. So when we do our rise, we're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, rise. And then we're going to run 1, 2, but that 2 is actually 4. And then we need to simplify that to a simpler form of the fraction. So 18 divided by 2 is 9, and 4 divided by 2 is 2, and that is the simplest form of the fraction there. Okay. Number 9, this one is a little bit off, so I'm going to just show you where my pretty points are. There's always one at the origin with proportional graphs. So we're looking at, they're a little bit off, so I'm going to show you where they are. So we have, we're looking for the rise over run. And we'll have, so we're going to go from rise is going to be 1, but we need to make sure to pay attention to our interval because we have 2, 4, 6, 8, 10. So it's actually a rise of 2 and a run of 1, 2, 3, but we need to check the interval again. So 2, 4, 6, 8. So we're actually going over not 3, but 6. So it's 2, 4, 6. And then we simplify that to 1 over 3. Number 10, okay, let's find, again, proportional graphs always pass through. So we're finding the next pretty point on the graph, and we see here that's where our next pretty point is. So we only need 2, but if you found the other one, it would be there. You just need 2, so the rise, we see here we still have that 2, 4, 6, 8, rise of 8, and a run of 2, 4, 6, 8, 10. So 8 over 10 can be simplified. 8 divided by 2 is 4, 10 divided by 2 is 5, and 4 over 5 cannot be simplified anymore, so that is your slope. So, and it said to describe the meaning of the slope. So if you notice here, this here is the time in how many hours, how far someone can walk. Or number 9, it's how much rainfall is going to happen over a certain amount of time. Or hiking, Benjamin, how far he can hike in each hour. So miles per hour, we have rainfall per hour, we have miles per hour on that one as well. Okay. So on number 11, it says explain why each of the graphs from the previous page are proportional. Use complete sentences and math vocabulary. So we know that each of these pass through the origin, and in order for a graph to be proportional, it has to pass through the origin and be a straight line. So, because each graph is linear and passes through the origin, it is proportional. Okay. All right, so on number 12, we have a bunch of different lines, and so let's start with line J. We're looking for the slope, so I'm going to highlight that. So we see that this is already a negative, so I'm just going to go ahead and put a negative there from the beginning, and we got to find some pretty points. So looks like these are all pretty points, and we only need 2. So my rise is going to be 1, my run is going to be 1, and so that's going to simplify to just -1. Okay, I'm going to use a new color for line K. So we got to find some pretty points. We know we can use the origin, and so from the origin we're going to go up, and this looks like the next one. So we got a rise of 1, 2, 3. And again, this is also a negative, so I'm going to just put that negative from the beginning. And a run of 1, so that's going to simplify to just -3. Okay, now we have line M. So we can use the origin. I'm going to erase this little amount. Okay, so we have the origin here, and we have another pretty point right here. So I'm going to go up 1, 2, rise of 2, and a run of 1. So that simplifies to 2. And our last line is this one. It's a positive line. And we know we have this, and there's the next pretty point is here. So our rise is going to be 1. It's getting a little messy in there. And the run is going to be 1, 2, and that cannot be simplified anymore. So that is your slope. So this one's a little tricky just because it kind of gets all mixed up. Okay. So these last couple, so 13 and 14, it's just saying to come up with your own numbers that could represent a function. So I'm not going to do I'm going to just draw, so the one thing I haven't covered yet is a vertical line test. So if I were to draw something that was representative, if I wanted to find something that would represent a function, I would want to find something that would pass the vertical line test, meaning whatever line I draw, or whatever graph I see, it needs to only cross my graph at one point each as I move it across. So this is something that would, this passes the vertical line test. Meaning it is a function. Whereas if I were to draw something like, on the next one, if I were to draw something like this graph here, if I were to take my vertical line that I drew up here, and I were to stop right here, you notice that this pink line crosses the graph at more than one point. So this fails the vertical line test. So you can use those points and do from there. So that would not represent a function, okay? And number 15 and 16, what we're going to do is write an equation that represents the speed of the sloth. So what we need is some pretty points. It is proportional, so we can see the pretty points all along here. So we just need 2. So I'm going to use these first 2, and I'm going to do my rise as 1, 2, 3. So my rise is 3, and my run is over one space, but then when I look down at the bottom, I see that this actually only goes over 0.5. So 3 divided by 0.5 is 6. And so what we just found here, this rise over run, the y over x is my slope. So when I want to write my equation, it's going to look like this. Because from the proportional relationship here, we see y equals kx. Y equals kx is that vertical, that linear line that is proportional. This one right here. All right, so then what we're going to do is how long will it take the sloth to walk 5,280 feet? So 5,280 feet is the y value because we have our distance of y. So we can take our equation and substitute where we go because y is the feet equals 6 times x, which is the time, because that's what we're looking for. So we're just going to substitute accordingly. So we have 5,280 feet equals 6 times x. So then to get x by itself, we divide both sides by 6. 6 divided by 6 is 1. And then we're left with x equals 5,280 divided by 6. Leaves us with 880 minutes for a sloth to walk a mile, which is a very long time. And that is the review.